Welcome, dear student, to the course of Advanced Algorithm Analysis. This is our week number 6. In today's lecture, we will be talking about bubble sort algorithm, its theory, general example, and also analysis of the algorithm. If you remember, in the previous week, we studied about the insertion sort algorithm. As we all know that we can perform different operations over the data. For example, we can search an element, and for doing that, we have different types of algorithms. The two of the most popular algorithms for searching are linear search algorithm and binary search algorithm. We have studied those algorithms in details. And then after that, we move to the second operation that is common, especially in data structure. And that operation is called the sorting of data. Sorting means giving logical arrangement to the data elements. For sorting, different algorithms are available. Some of them are insertion sort algorithm, selection sort algorithm, bubble sort algorithm, merge sort algorithm, radix sort algorithm, bucket sort, etc. So we have studied one algorithm, and that was insertion sort algorithm. Insertion sort algorithm, as we know, is good for small data, and it works like sorting a hand of playing cards. We have studied the technique that is used by the insertion sort algorithm to sort the data items. And we also see the running time of the insertion sort algorithm, its running time in the worst case and also in the best case. So now we are going to explore another algorithm, and this is the bubble sort algorithm. So in today's lecture, we will start the discussion from, as usual, from the objectives, the outcomes, what you are expected to learn at the end of this lecture. And then we will start formally the introduction to the bubble sort algorithm, the theoretical aspect of the algorithm, some general examples of bubble sort algorithm. But our actual work will start from the last 2 points. We will give more time to bubble sort algorithm, its dry run, and then analyzing the bubble sort algorithm. We will consider two cases for the analysis of bubble sort algorithm. In the first case, we will consider the worst case analysis of the algorithm, and then we will study the best case analysis. So let us start with the objectives. At the end of this week, you will be able to understand the basic concept of the bubble sort algorithm, how it works, how it sorts data, what is the concept of phases or passes that the bubble sort algorithm uses for sorting out the data, and how it sweeps element, how it bubble out the largest or smallest element to the end or to the start of the array. So you would be able to understand these concepts. You will also understand the algorithm of the bubble sort, its pseudocode. And also, after studying the algorithm, you will be able to give it a dry run with the help of an example. And you will see we will be using digital whiteboard to explain the concepts of the algorithm or to learn how it actually sorts out the data. And finally, you will learn about the running time of the bubble sort algorithm. So these are the objectives for today's lecture. Okay, so the question is that what is bubble sort algorithm? Bubble sort is one of the oldest and most simplest sorting algorithm. Whenever we study sorting in computer programming, in data structure, analysis of algorithm, or in advanced analysis of algorithm, we start with bubble sort. You may wonder why we consider the insertion sort before studying the bubble sort algorithm. Uh, because the analysis that we did for the insertion sort algorithm, that was pretty much similar with the concept that you have learned. So in order to link the things, the concepts with one another, I uh, did analysis of the insertion sort algorithm before bubble sort algorithm. But for in general cases, people prefer to start with the bubble sort algorithm because this is the traditional algorithm, the oldest algorithm and the simplest algorithm available for sorting out the data. When we say simple algorithm, from simple we actually mean that the concept of the algorithm is simple to understand. The technique used by the algorithm to sort out the data is simple. And also from simplicity, we mean that it is simple to understand. And also from simplicity, we mean it is simple or easy to implement as well. But it has a cost. And the cost is that it is actually not an efficient algorithm, especially if you have a large items of data. So you can say you can use bubble sort algorithm for sorting out small amount of data, but it is actually inefficient on large data items. And how we know that? Well, obviously we know it from the analysis that we do to analyze the algorithms. So its running time, as we will see in a moment, is n square quadratic. So that is why it is an efficient algorithm. The technique of the bubble sort algorithm is very interesting and simple to understand, as I mentioned. How it works? In bubble sort algorithm, you have given a list of items and you are asked to sort out the data elements. So the element at the first location, the first position, it is taken and it is compared with the element at the second position. Comparison is the basic operation of bubble sort algorithm, as we will see in a moment. So at the beginning, we actually take the element at the first position and then we compare it with the element at the second position. If we are going to arrange the elements in ascending order, then you have to see if the first element is greater than the second element, or to put it in general form, if the number being compared is greater than the number to which it is compared, then we need to swap them out. And then we have to repeat the same procedure for the rest of the elements, that is for the second element and then for the third element and then for the fourth element, until we reach the end of the list. So this is the basic technique of bubble sort algorithm. Let me repeat. Bubble sort algorithm swap adjacent elements by comparing them with one another, starting from the first element. So for example, if the first element is greater than the second element, that is if they are out of order, if they are not in ascending order, you can say, then you have to swap them out. For example, the number that is being compared to the second number, the number at the second position, if it is greater, then swap them out. But what if the first number is not greater than the second? Then there is no need to swap because they are already in sorted form. So you have to swap the elements only if they are out of order. If they are already in order, then obviously there is no need to swap them out. And then you have to repeat the procedure for the element at the second location, and then for the element at the third location, and then at the fourth location, and you have to continue the process until you reach to the end of the list. So what does this mean? Actually, bubble sort algorithm, it will make a number of passes through the list of elements, and on each pass it compares adjacent element values, and if they are out of order they are swept. So bubble sort algorithm makes a number of passes through the list of elements, and on each pass it compares adjacent elements values. If they are out of order, they are swept. If not, they are kept. And then the algorithm repeats the process until no sweeps are needed, which indicates that the list is now in sorted form. It should be noted, however, that each pass has the potential of moving a number of the elements closer to their final positions. Like, it is the passes that we make over the data to move the elements in the proper location positions. So every pass will actually move a number of elements closer to their final positions, even though only the largest element of that pass is guaranteed to reach to the final location. What does it mean? That it at the end of each pass only one item will be able to move to the proper correct position or location. Well, as the bubble sort algorithm, as you can imagine from the discussion, that it uses comparison as a basic operation over the element. So for this reason, bubble sort algorithm is sometimes referred as a comparison based sorting algorithm. Right? So you have to make it clear that bubble sort algorithm, in the bubble sort algorithm, the basic operation is the comparison of the adjacent elements. So for this reason, it is actually referred to as a comparison based sorting algorithm. Now, moving towards the technical details of how the algorithm works, let us consider a list of numbers, and they are stored in memory, for example in the form of a linear array. And as you know that while working with algorithms, we start the indexes from 1. So a1 actually refer to the first element of the array, a2 actually refers to the second element stored in the array, and an actually refers to the last element stored in the array. Now how it works, let us consider step number 1. As I mentioned, the bubble sort algorithm start working by comparing the first two elements. So element 1 is at a1 location, while the element 2 is at a2 location. So first thing first, you have to compare a1 with a2. And on the basis of this comparison, you have to arrange them in desired order. And what is the desired order? As earlier I mentioned that for most of the examples we consider that we are going to sort out the data in ascending order. So the desired order is that a1 must be less than a2. And another supposition that we usually take is that no two elements in the array are equal, or no identical values are present in the array, because it will make our job complex. So we take this consideration while studying algorithms. So first step, compare the adjacent element, the first two adjacent element, that is a1 and a2. And if they are out of order, what does it mean? Out of order mean that, for example, if a1 is greater than a2, then you have to swap them out. So the desired order for us is that a1 must be less than a2. Okay. After comparing the first two adjacent elements, you now have to compare the next two elements, that is a2 and a3. So compare a2 and a3 and do the same thing. Arrange them in a logical order. What is logical order? Logical order is that a2 must be now less than a3. So during comparison, if you find out that A2 is greater than A3, then you have to swap them out, because the order required is that A2 must be less than A3. And that is only possible after swapping them out. So first you compare the first two adjacent element and then the next two adjacent element, that is A2 and A3, and then carry on. Now you have to compare A3 and A4, element at the third location and element at the fourth location, and do the same thing. Arrange them in a logical order such that A3 must be less than A4. If they are already in sorted form, that is, if A3 is already less than A4, then there is no need to swap. However, if A3 is greater than A4, then you have to swap them with each another. And then we have to continue until we compare the final two elements of the list. So the final two elements are, the second last element is at a n minus 1 location, and the last element is referred by an. So we begin by comparing the first two elements and we end it comparing the last two elements with one another, and then do the same thing. After comparison, if you find that the second last element is greater than the last element, then you have to swap them out. If they are already in sorted form, then there is no need to swap them out. Okay, this is one step, or this is one pass of the algorithm, or one phase of the algorithm, in which only one element will pop out. One more thing about bubble sort algorithm. Sometimes people ask question, why bubble sort is called a bubble sort algorithm? Well, the concept is very simple. As from step number 1, it is clear that the largest element present in the list will bubble out to the last location. For example, 50 is the largest element in the list. So at the end of first pass or first phase, you will see that the largest element, that is 50, will bubble out to the end of the list. That is why it's called bubble sort algorithm. Now moving onward, at the end of phase number 1, you will observe that actually this step number 1, involve n minus 1 comparison. Why not n? Okay, suppose you have 5 elements and you want to compare them with one another. So first you have to compare 1 with 2, which will give you 1 comparison, and then you have to compare 2 with 3, which will give you 2 comparison, and then you have to compare 3 with 4, which will give you 3 comparison, and then you have to compare 4 with 5, which will give you 4 comparison. So you have 5 elements, but you did 4 comparison, which means n minus 1. So in our case, 5 minus 1 is equal to 4, so it will give you 4 comparisons. So it is important to remember that at the end of step number 1, the bubble sort algorithm actually performed n minus 1 comparison, while n is the total number of elements in the array. And second observation, as I mentioned, is that at the end of this step, the largest element will bubbled out or bubbled up to the nth location, or to the final location, or to the correct destination. So at the end of this step, we will see that a of n, mean the final element of the array, will contain the largest element in the list. And then you have to carry on with more steps, more phases, more passes. So move to the step number 2. Now, in this step, you have to repeat the same operations, but with one less comparison. That is, now we have to stop after we compare and possibly rearrange the last 2 elements. But now the last element is already in sorted form, so you do not need to make it part of the operation. So our last two elements are now an minus 2 and an minus 1. So let me repeat. In this phase, in this pass, in this step, you have to repeat the same things, but now with one less comparison. Why one less comparison? Because one element is bubbled out to the end of the list, and now it occupied an. So you don't need to make it part of the comparison process. That is why we will be performing one less comparison now. And for that we have to stop after reaching or after possibly rearranging the last two elements, which is now an minus 2 and an minus 1. It is important to note that in the step 1 actually involves n minus 1 comparisons, but now step 2 will contain n minus 2 comparison because one less than the previous step. So at the end of step 2 we have to, during step 2 we have to perform n minus 2 comparisons. And then at the end of this step you will see that the second largest element will bubbled up, will bubbled out, will reach to the correct location, and the correct location is an minus 1, right? So at the end of step number 1, the first largest element was bubbled out, and now at the end of step number 2 the second largest element will bubbled out. And another observation that during step 1 we performed n minus 1 comparison, but here we have to do one less comparison, and there is n minus 2 comparison will be here. Similarly, you have to repeat the same process in the next phase, in the next pass, in the next step. So repeat step 1 with, now you have to do one more less comparison. So for example, in step number 1 you did n minus 1 comparison, in step number 2 you did n minus 2 comparison, and then now in step 3 you have to do n minus 3 comparison. So you have to stop after comparing and possibly rearranging the last two elements. But now our last two elements are n minus 3 and n minus 2. And then at the end of this phase, this step, the third largest element will bubble out, or it will reach to the correct location. Okay, you have to repeat until you reach to step n minus 1. Remember why step n minus 1? Why don't we do the process for n times? Because if you have 5 elements, then you need only 4 comparisons. If you have 4 elements, then you need 3 comparison. If you have 3 elements, then you need only 2 comparison. And if you have 2 elements, you need only 1 comparison. What about only 1 element? Remember, array of 1 element is already in sorted form. There is no need to compare it, and there is no number to compare it with. So that is why we performed n minus 1 comparison. And then you have to repeat the same process. For example, you have to compare a1 with a2, and then you have to rearrange them if they are out of order, and then a2 to a3 and so on. So after the last, at the last step you have to compare only 2 elements, and that is a1 and a2, and then you have to rearrange them. And then at the end of this step you will see that all the elements are in sorted form now, or you can say that the array is in sorted form at the end of step n minus 1. So this was some theoretical aspect of the bubble sort algorithm. To make things a bit animated, let us see a video. By the way, I will play the video without sound, but if you want the video with sounds, with music, please search the video on YouTube and play it there. Here you will see it without sound. And the video is about bubble sort algorithm. It is actually an animated version of the bubble sort algorithm. So let us see the video. Okay, guys. So, what is what is your conclusion of after watching the video? Or in other words, what you learned from the video? What was happening? Only dance or something else? Actually, the video was about how the bubble sort algorithm sort out data. So if you observed keenly, they started with the adjacent elements and they sweep the elements if they are out of order. and then they repeated the process again and again until the largest element reached out to the final location. If you did not get an idea from the animated video, let us consider a general example. Okay, so in order to understand the procedure, let us consider an array which have elements 7, 1, 5, 4, 9, 2, 3, 10, 8, and 6. If you see the data is in unsorted form, so that is a problem. An algorithm actually solve a problem, a step-by-step procedure to solve a problem. So let us solve this problem by using bubble sort algorithm. So first thing first we need to compare the first two element at location number 1 and element at location number 2. So you have to compare 7 with 1, and you have to swap them if they are out of order. So after comparing 7 with 1, we observe that A7 is greater than 1, then you have to swap them out. So you can see here we swapped 1 with 7. Now 1 is at the first location and 7th is at the second location. And then you have to repeat the same process until you reach to the end of the list. So you have to compare the second element with the third element, that is you have to compare 7 with 5. As we know that 7 is greater than 5, then swap them. You see 5 is now at second location while 7 is at the third location. Repeat the process. Now compare element at the third location with element at the fourth location. So compare 7 with 4. After comparison, we observe that 7 is greater than 4 as well. So you have to swap them out. You see 4 is now at the third location while 7 is at the fourth location. And then repeat the same process. Now compare 7 with 9. Now here we do not need a swap because the elements are already in sorted form. So if they are already in sorted form, for example 9 is already greater than 7, then there is no need of swap. Go ahead, repeat the process. Now compare 9 with 2. As we know that 9 is greater than 2, we have to swap them out. Swap them and then continue. Now compare 9 with 3. As 9 is greater than 3, you have to swap them. After swapping, go ahead, compare 9 with 10. As we know 10 is greater than 9, so swap them out. Like this. Sorry, after comparing 9 with 10, we know that they are already in sorted form, so there is no need to swap them out. So 10 will be at his location. And now compare 10 with 8. So 10 is greater than 8, swap them out. And finally do the last comparison, that is compare the element at the n-1 location with the element at the n location. After comparison, we observe that 10 is greater than 6, so you have to swap them out. Now 10 is at the last location. This is pass number 1, or this is phase number 1 or step number 1 of the bubble sort algorithm. Remember, at the end of each step the largest element bubbled out. So let us see this array. What is the largest element here? That is 10. So at the end of first step, the largest element will bubbled up or bubbled out to the last location. So we see here the 10th is now at the correct location here. Okay, one more thing. We actually performed n-1 comparison in this step. And at the end of this step, only one element will reach out to the final location. Now you have to repeat the same process for the second step. Same process mean you have to compare all the adjacent elements. However, one less comparison. Total number of elements are 10, for example. Then you have to perform 9 comparison in step number 1 and 8 comparison in step number 2. So here you have to ignore the element at the final location because it is already in sorted form. So there is no need to compare it or make it part of the process. So starting with the adjacent element, compare element at the first location with element at the second location. So at first location we have 1, while at second location we have 5. So they are already in sorted form. Logical order, 5 is greater than 1, so there is no need to swap. Go ahead. Now compare element at the second location with element at the third location. After comparison, we saw that 5 is greater than 4. There is a need of swap, so swap them out. Go ahead. Compare 5 with 7, no need of swap. Compare 7 with 2. Okay, 7 is greater than 2. Swap them out, interchange them. And then compare 7 with 3. Again, 7 is greater than 3. Then you have to interchange these elements. So 3 will take the location of 7 and 7 will take the location of 3. Go ahead, compare 7 with 9. Already in sorted form, no need to swap to interchange. Go ahead. 9 is greater than 8. Yes. So you have to swap them out. Here is the swapping. Go ahead, compare 9 with 6 now. So 9 is greater than 6. You have to swap them. Now you have to stop here. Do not go ahead, or the algorithm will not compare it with the final element because final element is already in sorted form. At the end of second phase or second pass or second step, the second largest element will bubbled out. So the second largest element is 9 and it reach out to its correct position. Step number 3, same process but now with 2 less comparisons or 1 less comparison as compared to the previous step. Repeat the same process, starting with comparing the adjacent elements and swapping them out if they are out of order and leaving them out if they are already in sorted form. So first compare 1 with 4. 1 is greater than 4? No. So it means they are already in sorted form. There is no need of swap. Go ahead, compare 4 with 5. Again sorted form. Go ahead, compare 5 with 7. Sorted form. Go ahead. 7 is greater than 2. Yes. So you have to swap them out, interchange them. Then compare 7 with 3. Again 7 is greater, so swap them. Now compare 7 with 8. Oh, they are already in sorted form, so there is no need to swap. Compare 8 with 6. 8 is greater than 6, so you need to swap them out. Here it is. And then you have to stop here. Now at the end of third iteration or third phase or pass, we have 3 elements in sorted form. And at the end of this step, the largest element in the unsorted list is popped out to the correct location. Finally, you have to move forward. Continue until you reach out the final step. Okay, now moving toward the algorithm. Here is the algorithm for the bubble sort algorithm. For the bubble sort, at step number 1, we are actually using for loop. Pass actually denotes the steps that we consider in the examples, or you can say it is actually the number of phases or passes over the data. So how many passes are actually required? N minus 1. So the for loop will start from 1 and it will repeat until the value of pass reach to n minus 1. Remember, we need 1 less comparison. So in this case, you can see that we are actually doing 1 less comparison. And then step number 2, another loop, another for loop. And this loop is for comparison. COMP stand for comparison. And as you know, for each step, at the end of each step, we have to do 1 less comparison. So that is why the loop will work till n minus pass. So for example, at the beginning, the value of pass is 1. So n minus 1, same thing. But then for the next phase or pace or pass, we have to decrement it. So now the value of pass will be 2, and you will see that n minus 2 will give you one less comparison. Why we are doing this? Because at the end of each pass we required one less comparison. And then the actual things happened at 3. Sweeping. That loops will control the iterations, it will control the comparison, while the sweeping will happen at step number 3. So we have to compare the two adjacent element. For example, at the beginning we have to compare element at first location with element in the second with element at the second location, and if they are out of order we will need to sweep them out, right? So compare the two adjacent element, and if they are out of order you have to interchange them. It is important to understand how we actually interchange the values of two variables. For example, in this case we need the help of a third variable, and we are calling the third variable, we are giving it a name temporary. So first you have to assign the value of the location, the first location, to the temp variable, and then you have to assign the value of the second location to the first location. Once you do this assignment, the value stored at a comp will be lost or will be overwritten, but we do not worry because we have already taken or saved the value of a comp in the temp variable. So if we overwrite, the value doesn't matter. So this is actually sweeping. You have assigned the value of the second location to the value of the first location. Now it's time to assign the value of the first location to the value of the second location. So the value of the first location has already been saved in the temp variable. So it's time to assign the value of the temp variable to the value of the second location, a comp plus 1. Actually it is interchanging the value of the comp with the value of comp plus 1. But for doing that we need the help of a third variable, and that is temp. So first we assign a comp to temp, and then we assign a comp plus 1 to a comp. But when you assign a comp to a comp plus 1 to a comp, the previous value will be lost. But don't worry, because we have a copy in the temp variable, and then you have to assign the value of the temp variable to the a comp plus 1, and that's final step. Remember, here we are dealing with multiple loops, multiple for loops, nested loop. In case of nested loop, the first loop is the outer loop, while the second loop is the inner loop. For one value of the outer loop, the inner loop will execute till this condition, right? For one value of the outer loop, for example, pass is equal to 1, it will execute up to n minus pass times. Once you have evaluated this condition, the control will return to the inner loop, and then you have to check the condition. If it is true, then you have to execute the process again and again until the condition become false. Once the condition in the inner loop become false, the control will transfer to the outer loop, which is here, and then you have to increment the value of pass by 1 in the for loop, and then for that value you have to repeat the same process again. So this is the bubble sort algorithm. Now it's time to take an example or give a dry run to the algorithm. But for doing that, I actually need to take a short break, because I'm going to make use of a digital gadget, that is a USB pen tablet, and also I need a digital whiteboard. So I will make necessary arrangement here and then we'll come back. So let us take a short break and we will meet again very soon.